All right, so number 11, still solving exponential equations. So we have 3 to the 4x plus 1 is equal to 9. So we're going to rewrite 3 as a base of, rewrite 9 as a base of 3. So that will give us 3 to the 4x plus 1 equals, and we can rewrite 9 as 3 squared. All right, so now that these two bottom numbers are the same, we're focusing on this top part. So we get 4x plus 1 equals 2, just right across the other side of the equal sign. And then as we solve, we would subtract 1. So minus 1 would give us 4x equals 1. And then we would divide by 4, which will give us x equals 1/4. Okay. And as you do these, I would recommend plug that in to your calculator and verify that you get 9. Okay, so always you want to get in the habit of checking. I've just been a little bit sloppy with checking, or overconfident, I guess I would say. Second, quit. I'm going to clear this out. I'm going to type in this expression, but I'm going to put 1/4 and make sure I get 9. We're going to say 3 raised, open parentheses. We're going to say 4 times 1 divided by 4, because that's what we got for x, and then plus 1. And then I'm going to close that up there. So all I did was replace the x with 1/4. When you solve that, you get 9 the other side, so you know that you've done it right. So our solution was x was 1/4. Okay, so this number 12, same concept, except we have, multiple moving parts. But we're going to do the same thing, try to get all the bases the same, and then solve it. So this time we have 9 to the x power times 3 to the x squared power equals 81 to the second power. I want to try to get them all in the smallest one if possible, so that would be 3. We can rewrite 9 as 3 squared, and it was raised to the x power. So that's the 9 raised to the x power. This one is already a base of 3, so that is 3 to the x squared power. And then over here, 81, we can rewrite that as 3 to the 4th. So you have to use that power table if that's not one that you know. And then it was squared. All right, so we're going to do property of exponents. Power to power. Okay, kind of saw those in the overview. Multiply those. So we have 3 to the 2x power times 3 to the x squared power equals 4 times 2, 3 to the 8th power. Now we're almost there because we only want 1 3 on each side. So what we need to do, one more thing, property of exponents, if you have the same base and you're multiplying, you add these two together. So this is going to give us 3 to the 2x plus x squared power equals 3 to the 8th power. So now both sides are the same with one base of 3. Then we set this part equal. All right, I'm just going to go over here to the other side. So this means we have 2x plus x squared equals 8. This looks like a quadratic equation, so I'm going to set it all equal to 0, and I'm going to write it in standard form. So I'm going to write the x squared out front, and then plus 2x, and then subtract and move the 8 over. Minus 8 equals 0. So let's see if this guy will factor first before I go and try to do quadratic formula. So factors of 8, because 1 times 8 will give us 1 and 8 2 and 4. And we want to subtract to get 2. These two will subtract and give us 2. So it should factor. We get x in each, and then we get a 2 and 4, because those are our factors. First sign going left to right is the bigger sign. So, or the bigger number gets the first sign, and then the second sign tells me these are different. So negative. So we have x equals 2 from this one when you set it equal to 0. And then we get x equals negative 4. All right, we got 2 possible answer choices. We can only have one answer. Both of them shouldn't work. Just guess, I would say the positive one, but let's check it because you want to verify this. And then it says separate with the comma, so it's possible that they both could work, but let's see. We're going to say 9 raised to the second times 3 raised, we're going to say parentheses to the second squared, okay, because we have a squared on that one. So on this side, when I do that, what do we get? 65, 61. Is that equal to 81 squared? 81 squared. We got 65, 61. All right, so now I'm going to check to see if I get the same thing with the negative 4. So I'm going to do second enter. I'm just being lazy. Second enter recalls the last thing. If I do it again, second enter, it'll bring my equation back up. So I just want to type over and change this to a negative 4. So I'm going to do second insert. The delete button allows me to add a character negative. And then I'm going to go back and type over that with 4. So I got to move my cursor. If you just start typing, so like if I came over here and you see how this is 9 raised to the second power. If I just start typing a negative, it just types over that and it gets rid of it. So I have to do second insert to be able to add an extra character. So negative 4. All right, so let's check that out. And we get this, which is not the same as 65, 61. So the x equals negative 4 doesn't work. And we want to use x equals 2. Do they both work? Oh yeah, the negative 4 gets squared. I don't know. It didn't show. I got 2. Let me see. Do they want the negative 4 as well? I thought I just checked it. Maybe I didn't. Yeah, negative 4, negative 1. I did. Well, let's see. I'm thinking it's not working. Negative 4. Do they want them both? I guess they do. I don't know. I don't know if I've done something wrong. Let me see this one more time, because it didn't look like they worked. They both worked out. Let me clear this and try it one more time. So let's say 9 raised to the negative 4. And then we're going to do times. Maybe I should put this in parentheses. Second. Nope. Parentheses, second, insert, negative, move forward and back, we get a 4, close it. Alright, so that's that part. And then times, we'll do 3 raised, negative 4. Maybe I didn't type it in right. That should be squared on the outside. Like that, yeah. Okay, yeah. So I didn't type it in correctly. It was a calculator error, human error. Okay.